Hello everyone. Our today's topic of discussion is trigonometry. This video is basically for students who are preparing for the SAT exam. Okay. Now, in this video, what we'll be doing is we'll be understanding the basics of trigonometry only from the perspective of SAT exam. Okay. Trigonometry as a chapter or as a concept in maths, it's extremely huge, right? Like it's so many concepts, so many formula that there's technically no end to it, right? It's a topic which can go on for almost like 40 to 50 hours also, okay, if one starts teaching trigonometry. But we will not be going into that. We will only be sticking to the right angle triangle trigonometry and the very elementary formulas, very basic rules, very basic concepts which will be required for you to ace the SAT exam. Okay. Now we'll be starting with basics, and after that we'll be taking up a couple of SAT questions that you can expect in the exam and the questions which have already appeared in the exam. So you can expect a question or two marks to marks as far as trigonometry is concerned. Now, although the SAT is now going digital, right? So still, I don't think you can expect more than a question or two, because now you'll be having like 20 questions. So still, a question is more than sufficient as far as trigonometry is concerned. All right. Anyways, we'll be understanding the trigonometry from the scratch. So if you haven't studied trigonometry at all, there's no problem. We'll be doing it from the scratch. All right. Let's get started from the basics of trigonometry. Now, what exactly is trigonometry? If you want to understand that in a layman's language, trigonometry is basically the branch of mathematics that relates angle of a triangle to side of a triangle. So it basically relates angle of a triangle to side of a triangle. This is basically what trigonometry does. Okay. Now we will only be focusing on the right angle triangle, although trigonometry can be applied to like other triangles also, acute angle triangle, obtuse angle triangle, but we will only be using it for right angle triangles. All right. So let's start. Let's make a right angle triangle. This is P, this is Q, this is R, this is 90 degrees, and let's say this angle R is some angle theta. Okay, this angle R is some angle theta. Now there are basically 6 trigonometric functions on which we need to work upon, which basically relates your sides to your angles. So first of all, let's call PQ as A, QR as B, and PR as C. Now the 6 trigonometric functions are basically, the first one is sine. So let's say sine theta. So what exactly is sine theta? Sine theta is nothing but opposite side divided by the hypotenuse. So sine theta will simply be equal to A by C. Second is the complement of sine, which is also known as cosine. So cosine theta, cosine is nothing but the adjacent side divided by hypotenuse, so that is simply B by C. Now these are the two elementary functions in trigonometry. The other functions can be derived using these two functions. Effectively, there is only one, which is sine. Cosine is also complementary of sine, and the others can be derived with the help of sine and cosine itself. All right. Okay. The third one is known as the tangent, the tan function. So I'm going to simply write tan theta. Now what's tan? Tan is nothing but sine theta divided by cos theta, or it's like opposite side divided by the adjacent side, so that will simply become A by B. Then the next one, you can also do the inverse of tan, so that's like basically that's known as cot, which is basically like cos theta by sine theta, and that's like B by A. Then you can do inverse of sine, so this is 1 by sine theta. Now this is known as cosecant theta, which is also known as cosec, COSEC. So that is basically equal to C by A. Then the last one is basically the inverse of cos. which is basically known as secant theta, and that will simply be equal to C by B. So we can say that I'm going to use another color. So cosine is basically complementary of sine. Cotangent, which is basically cot, is complementary of tangent or tan, and cosecant is basically complementary of secant. That's why we are adding the word co in the prefix part. Okay, so you have basically 6 trigonometric functions, which is sine, cosine, tan, cot, cosec, and sec. Now effectively there has to be only 6 trigonometric functions possible, and this is not only true for right angle triangle trigonometry. This is basically true for any kind of a triangle that you'll ever come across. The reason being is that there are 3 sides to a triangle, right? And in order to come up with any of the ratios, you require 2 sides. So out of 3 sides, you need to choose 2 sides that in maths can be written as 3C2. Now the order matters, which means whether you do A by C or C by A, the 2 ratios will be different. So the order matters, which means you will simply be doing 2 factorial, which means there are like 6 possible ways. Even if you don't know this is completely fine, which means you ought to have 6 trigonometric functions. That's the whole point, nothing else. Anyways, what you need to remember is that, let me just go through this once more. Sine of an angle in a right angle triangle is always the opposite side by hypotenuse. Cos is adjacent side by hypotenuse. Tan is sine by cos, which is opposite by adjacent. Cot is cos by sine, which is adjacent by opposite. Cosecant is 1 over sine, which is hypotenuse divided by opposite, and secant is 1 over cos, which is hypotenuse divided by adjacent. These are like these 6 basic trigonometric functions which we need to know. Now, if angle R, let me write this R here again. If this angle R is theta, Q being 90, I can very well say that this angle P will basically be equal to 90 minus theta. This angle P will very well be equal to 90 minus theta. Now let's calculate sine, cos, tan, cosec, sec, cot for this angle P also. So let's say we have sine 90 minus theta. Again, we'll use the concept that sine is nothing but opposite by hypotenuse. So this will become B by C. If we talk about cos 90 minus theta, that is adjacent by hypotenuse, that is A by C. Then it's tan 90 minus theta, that is sine by cos, that is B by A. Then it is cot 90 minus theta, so that is A by B. Then it is cosec 90 minus theta, that is 1 over sine, which is C by B. And then it is sec 90 minus theta, that is 1 over cos, and that is equal to C by A. So I have written the trigonometric function for the other angle also. Now you need to remember that if in a triangle sum of 2 angles is equal to 90 degrees, then the 2 angles are said to be complementary in nature. Everyone knows this, right? So what we have done here is that we have written trigonometric functions for an angle, and we have also written trigonometric functions for its complementary angle, because 90 minus theta will automatically become complementary of theta. Now the point to be noted here, there are a couple of things which we have to note here. First, if you'll observe carefully, you'll realize that the value of sine theta is equal to cos 90 minus theta. You can see that they both are equal to A by C. Second is cos theta is equal to sine 90 minus theta, which means they both are B by C. Tan theta is cot 90 minus theta, they both are A by B. Cot theta is equal to tan 90 minus theta, they both are B by A. Cosec theta is equal to sec 90 minus theta, they both are C by A, and sec theta is equal to cosec 90 minus theta, which is equal to C by B. Now, in case of SAT, they don't ask cot, cosec, and sec. They are more inclined towards sine, cosine, and tan. So the first set of properties which you need to know is sine theta is equal to cos 90 minus theta. Now, I'm going to write the remaining two also. Second is tan theta is equal to cot 90 minus theta, and sec theta is equal to cosec 90 minus theta. That's why they are known as complementary. You can see that their complements are equal basically. Right? That's why sine, cosine, tan, cotan, sec, cosec. Alright. So this is the first set of properties which you need to remember. I'm sorry, I'm short of space. So if you can just note this down, you can pause the video and note these three properties, and then we can probably move on further. Alright, let's move on. So this is the first set of properties which you need to remember, which will be used while we'll be solving the question. Now, another thing that we can observe from here is that, now let's remove this, we don't need this any further. Let's focus on these two, sine theta and cosine theta. That should be A. Okay, now sine theta is A by C, cosine theta is B by C. I'm going to remove the complementary part because we don't need this anymore. Let's just remove this. So sine theta is A by C, cosine theta is B by C. Let's square them up on LHS as well as on RHS. So sine theta A by C will basically become sine squared theta, which is equal to A square by C square, and cos squared theta will become B square by C square. Let's add both the equation. This is equation 1, this is equation 2. So I'm going to get sine squared theta plus cos squared theta is equal to A square by C square plus B square by C square, which is equal to A square plus B square by C square. Now, this PQR is a right angle triangle, right angled at Q, C being the hypotenuse, A and B being the legs, which means you can very well use the Pythagoras theorem. And what's a Pythagoras theorem? That is, in any right angle triangle, hypotenuse square is equal to sum of the squares of the other two sides. So A square plus B square is nothing but C square. So this is C square by C square, which is simply equal to 1. Which brings us to our second set of property. That is, I can simply write sine squared theta plus cos squared theta is equal to 1. Sine squared theta plus cos squared theta is simply equal to 1. Now, moreover, what we can do with this is, so let me remove this part. We don't need this anymore. This is basically where my second set of property begins. Okay. So sine squared theta plus cos squared theta is equal to 1. Now let's divide this entire equation by sine squared theta, that is on the LHS as well as on RHS. So sine squared theta by sine squared theta is 1. Cos squared theta by sine, now cos by sine we defined it as cot, and 1 by sine square is cosec. Okay. Another thing that we can do with this equation, which is sine square theta plus cos square theta is equal to 1, I can divide both sides by cos square. So sine square by cos square is tan square. Cos square by cos square is 1. And 1 divided by cos square, 1 by cos was defined as sec. So 1 by cos square will become sec square. This is the second set of properties. So we have learned two things till now. If you have a right angle triangle, then sine theta is equal to cos 90 minus theta. Tan theta is equal to cot 90 minus theta, and sec theta is equal to cosec 90 minus theta. Second set of properties which we learned was sine squared theta plus cos squared theta is 1. Tan squared theta plus 1 is equal to sec squared theta, and 1 plus cot squared theta is equal to cosec squared theta. These are the two things that we have been able to figure out, actually not learn, we have been able to figure out these two things as far as the right angle triangle is concerned. Okay, now these are the very elementary properties which you need to use. Now mostly if you talk about SAT sticks to this one and this one, and then the basic part like how do you calculate sine, cos and tan, that is basically what SAT does ask you as far as trigonometric part is concerned. Now there is one more thing that we will be understanding in this, and that is like how do you convert angles from degrees to radians. Okay, that is like another thing that we need to know as far as the basics of trigonometry are concerned. Now whenever you measure angles, there are two ways in which you can measure angle. One is you can measure them in degrees, another is you can measure them in radians. Now there is a very simple relationship between the two units. Remember that 360 degrees is always equal to 2 pi radians. Or you can say that 1 degree is equal to 2 pi by 360 radians. Like whichever way you want to calculate, you just need to remember that 360 degrees is always equal to 2 pi radians. So some of the basic ones that we use is 360 degree is equal to 2 pi radians. Then 180 degree is equal to pi radians. 90 degree is pi by 2 radians. 60 degree is pi by 3 radians. 30 degree is pi by 6 radians, and 45 degree is pi by 4 radians. You can calculate the others also, like 120 is 2 pi by 3 and all those things you can calculate, but these are the general ones that we use. And more often than not, in case of SAT, I don't think you will get anything beyond 90 degrees. So pi by 2 is something that you will see oftenly. Apart from that, you will not see anything else. Now, apart from this, the other thing that you need to remember is that there are like some certain angles for which you need to remember the value of sine, cos, tan, right? So I'm going to make a table, and in that table I'm going to write the corresponding values, the angles and the values of sine, cos and tan. So for 45 degrees, let me just write it here itself. This is pi by 4. Okay. This one table you have to remember a couple of values. There is actually no other way out. So the basic 5 angles for which you need to remember is 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. So you have sine, you have cos, you have tan, then you have cot, you have sec and you have cosec. Angle followed by their complementary angles. Now just remember the value for sine. Apart from that, it's very easy. So sine 0 is 0, Sine 30 is half. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2 and sine 90 is 1. So 0, half, 1 by root 2, root 3 by 2 and 1. These are the 5 values which you need to remember. Now what happens in case of cos? These values are exactly reversed. So sine is 0, half, 1 by root 2, root 3 by 2 and 1. For cos it will become 1, root 3 by 2, 1 by root 2, 1 half and 0. Why? Because cos is nothing but complementary of sine. Now we know that sine theta is nothing but cos of 90 minus theta, so use that logic. So whatever will be the value of sine of theta will be the value of cos of 90 minus theta. So if sine 60 is root 3 by 2, then cos of 90 minus 60 will be root 3 by 2. Now what is 90 minus 60? That is 30 degrees. That's why sine 60 and cos 30 are exactly the same. That's the logic. Now what is tan? Tan is sine by cos. So let's quickly take their ratios. 0 by 1 is 0. Half by root 3 by 2 is 1 by root 3. 1 by root 2 by 1 by root 2 is 1. Then this is root 3 and 1 by 0 is not defined. So I'm going to write ND for it, not defined. What is cot? Cot is cos by sine, exactly the opposite of tan. So 1 over 0 not defined. Root 3 by 2 by half is root 3. 1 by root 2 by 1 by root 2 is 1. Then 1 half divided by root 3 by 2 is 1 by root 3. And then 0 by 1, which is 0. Again, you can see that the values of cot is exactly the complementary of that of tan. Okay. Next is cosec. Cosec is 1 over sine. So 1 over 0 is not defined. 1 by 1 half is 2. 1 divided by 1 over root 2 is root 2. 1 divided by root 3 by 2 is 2 by root 3 and 1 by 1 is 1. Sec is 1 over cos. 1 by 1 is 1. 1 divided by root 3 by 2 is 2 by root 3. 1 divided by 1 by root 2 is root 2. 1 divided by 1 half is 2 and 1 divided by 0 is not defined. Exactly the complementary of cosec. So this is the table which you need to remember. Now they will not be asking you cot, sec, cosec. They don't do that as far as the set is concerned. Just remember these two. This is like more than sufficient. And if in case they ask about tan, then okay, remember for tan also. Otherwise, if you remember it for sine, you can basically remember it for each one of them. But just remember these values. This will actually be helpful. Okay, so this is like the basics, the couple of like properties which you need to know. How do you convert degrees to radians and like couple of angles with their respective value for trigonometric functions. These are the things which you need to remember so that you can attempt like questions of trigonometry in your SAT exam. All right. Okay, then let's move on to questions now. So let's try question number 1. Why don't you guys pause the video and try this question once by yourself? Then I can solve it for you. Go ahead, pause the video and try this question. Alright, let's try this question. In a right angle triangle, let's first of all draw a right angle triangle. The tangent of one of the two acute angles. So let's say we are talking about tan of this angle P. Let's call this P. So tan of P is given to me as 1 over root 3. Now I know that tan is 1 over root 3 whenever the angle is 30 degrees, which means this angle will simply be equal to 30 degrees. That's why you need to remember this table. So you can say that tan is 1 over root 3 when it is 30 degrees. So tan of one of the two acute angles is 1 over root 3. So I took that one angle to be P. You could have taken it to be R. It doesn't matter anyway. So tan P is 1 over root 3, which means angle P has to be what? Angle P has to be 30 degrees. If angle P is 30 degrees, I can simply say that angle R will be equal to 60 degrees. Okay. What is the tangent of the other acute angle? what is the tangent of the other acute angle. That means they're asking us the value of tan of r, or in short they're asking us to calculate the value of tan of 60 degrees. Now how much is tan of 60 degrees? It is simply root 3. So the answer is simply root 3. So again, if you know like tan 60, tan 60, tan 60 is how much? Tan 60 is 1 by, oh sorry, it's simply root 3. That's your answer. You're done with the question. That's it. So actually in case of SAT, trigonometry questions are really very easy. You'll be getting a question marks to marks, right? And these are like free questions, frankly. Very, very, very easy as far as SAT is concerned. Okay, give this second question a try. Now remember one more thing, all these questions that I'm going to solve in this video are going to be like SAT previous year questions, so that you know that okay, this is exactly what we need to do as far as trigonometry is concerned. If you go through this video like once, this is like you're done with your trigonometry. You don't have to study trigonometry from anywhere else as far as your SAT exam is concerned. Okay, so pause the video and try this question, please. All right, so sine of x being an angle, sine of x degrees is equal to a. Which of the following must be true for x? Okay. Now, if sine of x is equal to a, now I know that cos is complementary of sine. So one thing I can say is that cos of 90 minus x should also be equal to a, right? Because we know that sine and cos are complementary. So whatever will be the value of sine theta will exactly be the value of cos of 90 minus theta. So if sine of x degrees is equal to a, then cos of 90 minus x degrees will also be equal to a. Now which option says that? It's given in option number B. Oh, I think my bad, it should be cos, my bad, it should be in option number C. So cos of 90 minus 6 degrees will be equal to A. That's it. You're done with the question. See, again a very simple question. If you know sine theta is equal to cos 90 minus theta, you're done with the question. That's it. And these are actual SAT questions. Okay, let's move on. Pause the video and draw this question, please. Now, this question is basically a question for which you need to know the basics of similar triangles also, right? So if you are completely new to the concept of similar triangles, you can go to the channel and go to the playlist, hit geometry on that, and please study the similar triangles. Okay, so we can like type Binge's Education dash SAT plus GRE plus GMAT, go to playlist, then go to geometry, and then go to similar triangles. Okay, if you know, then this question is again a free question for you, because we know that if two triangles are similar, then their corresponding angles are equal. So if the two triangles are similar, that is triangle ABC is similar to triangle DEF, which means angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F, right? Whenever the triangles are similar, then their corresponding angles are equal. Now if the angles are equal, can I say that their corresponding trigonometric functions will also be equal? If the angles are equal, then sine theta will be equal to sine theta, cos theta will be equal to cos theta. Now they're asking us to calculate the value of cos of E. That is, they're asking us about this triangle, that is cos of E. Now instead of calculating cos of E, since the two triangles are similar and angle B is equal to angle E, instead of calculating cos of E, can I simply calculate cos of B? And I'm done with the question, right? Because E and B are equal. Two angles are equal, then their cosines have to be equal. So cos of B. Now how do you define cos? That is adjacent divided by hypotenuse. Your answer is simply 12 by 13. Your answer is simply 12 by 13. That's it. You're done with the question. Alright, pause the video and try this question please. Alright, let's see what we can do with this one. So triangle ABC above is a right angle triangle and sine of B is 5 by 13. That is, we are talking about this angle. So sine of B is 5 by 13. Now sine of B, now what is sine? Opposite side divided by hypotenuse. What is the length of side BC? Alright, they are asking us to calculate BC. Now if sine of B is 5 by 13, which is AC by AB, so we can say that 5 by 13 will be equal to AC, which I don't know, AB is 26. Now use the ratio, we know that 26 is 13 times 2. So AC will automatically become 10. AC will automatically become 10, so this is 10. Now you need to calculate BC, so for that you need the Pythagoras theorem. So you can say that AB square will be equal to AC square plus BC square. So 26 square is equal to 10 square plus BC square. So BC square is equal to 26 square minus 10 square. Now 26 square minus 10 square is in the form of A square minus B square. So this is like A plus B into A minus B. So this is like 36 into 16 and this is equal to BC square. So BC is equal to 36 into 16 to the power half. So you can take square root of both 36 and 16. So square root of 36 is 6, square root of 16 is 4. So BC is like 6 into 4, which is equal to 24. And that's your answer. Okay. So you're done with the question again. Probably in this case, if you're not good with calculations, you can make use of a calculator. But anyways, as far as the concept is concerned, it's pretty straightforward. Alright, let's try another one. Pause the video and try this question, please. Alright, let's give this one a try. So let's first of all draw a right angle triangle, because when you see a figure while solving a question, no, things are typically easy. So you have PQR, this is 90. The two acute angles of a right angle triangle have degree measures of x and y. Let's call this x and let's call this y. So sine of x is 12 by 13. Now sine of x is 12 by 13, which means this is equal to QR divided by PR. So QR by PR is 12 by 13. Now remember that this is a ratio. This is a ratio. So what I can do is I can write QR as 12K and PR as 13K. So this is 12K and this is 13K. Now you can use the Pythagoras theorem and you can say that PQ square plus QR square is equal to PR square. PQ square plus 144K square will be equal to 169K square. PQ square is equal to, now 169 minus 144 is 25. So this is 25K square and PQ will be equal to 5K. So this here will simply become 5K. Now what do you want to calculate? You want to calculate sine of y. So sine of y is opposite by hypotenuse. So that is 5K by 13K and that is equal to 5 by 13. That is equal to 5 by 13. And you could have solved this question the other way also. Like if sine of x is 12 by 13, let me just solve it here itself. if sine of x is equal to 12 by 13, then cos of y will also be equal to 12 by 13, right? Because y is complementary of x. So if sine of x is 12 by 13, then you can rewrite this as cos of 90 minus x will also be 12 by 13. Now what is 90 minus x? 90 minus x is simply equal to y. Okay. Now we know that sine square y plus cos square y is equal to 1. This is the property you remember, right? So sine square y plus cos square y is equal to 1. So in place of cos square y, you can put 12 by 13. And then also you can answer the question. So let me do that calculation here. So this becomes sine square y plus 12 by 13 square. So that's 144 by 169 is equal to 1. So sine square y is 25 by 169, or sine of y is equal to 5 by 13. Equal to 5 by 13. Whichever way you want to do it, you can solve this question, right? Okay, now one more question for this chapter and then we are done with this chapter, trigonometry. So pause the video and try this question, please. All right, let's try this one. So in triangle RST above, point W not shown lies on RT such that SW makes an angle of 90 degrees with RT. Okay, so we're gonna have W something like this, and this angle will be 90 degrees. Okay, so another thing is this is 12, this is 5. So one thing is for sure that this will be 13. How? You can use the Pythagoras theorem, because S angle is 90 degree. So you can say that RT square will be equal to RS square plus ST square. This is 12 square plus 5 square. So this is like 144 plus 25, which is equal to 169. You can simply say that RT will be equal to 13, because RT square is how much? It's like 169. Okay. Now I'm gonna take SW to be H, and let's take this to be X, and or let's do one thing. Let's take this WT to be X, and the remaining part, that is your RW, to be 13 minus X. Now why we have to do that? Because it's asking us to calculate the value of RSW, cos of RSW. Now in order to calculate the cos of RSW, we need RW, that's required, right? And same thing goes with WST also. Now let's use the Pythagoras theorem. So first of all, in triangle RSW, I can say that RS square, which is like 12 square, is equal to SW square H square plus 13 minus X whole square. Similarly, in triangle STW, ST square, that is 5 square, should be equal to SW square, which is H square plus X square. This is your equation number 1, this is your equation number 2. Now if I'm going to do equation number 1 minus equation number 2, 12 square minus 5 square, that is 144 minus 25. H square and H square are going to get cancelled. Then you will be having 13 minus X whole square minus X square. So 144 minus 25 is equal to 119, is equal to 169 minus 26x plus X square minus X square. These two are going to get cancelled, and 26x will basically be equal to 50, and from here x is equal to 25 divided by 13. X is equal to 25 divided by 13. So this value X is 25 by 13. So if you want to calculate 13 minus X, so this is equal to 13 minus 25 by 13. This is like 169 minus 25 by 13. That is 144 by 13. Okay, this question actually requires a lot of calculation. You can't do this other way around. Now, what's the value of cos of RSW? Now, cos of RSW, so that will be equal to the adjacent side, which is H, divided by hypotenuse, which is 12, minus sine of WST, so that is X divided by 5. So we are yet to calculate the value of H. We are not done with it. We have only calculated the value of X, which is like 25 by 13. So let's do that calculation also. So I'm going to remove this because I'll be requiring space to do more calculations. Now if the value of X is 25 by 13, this is what we have calculated. Let's put it back here. So 25 minus X square, which is 625 by 169, is equal to H square. So 25 into 169 minus, now 625 is like 25 into 25 divided by 169 is equal to H square. So in the numerator, I'm going to take 25 common. This will be 169 minus 25 divided by 169 is equal to H square. So 25 into 144 divided by 169 is H square. Now you can take roots on both the side. Square root of 25 is 5. Square root of 144 is 12. Square root of 169 is 13. So you'll get the value of H as 60 by 30. So lot of calculations is required in order to solve this question. Okay, now the value of H is 60 by 13. Put it in here. So this is like 60 by 12 into 13 minus X. Now what is X? X is 25 by 13. This is 25 by 13 into 5. So you can cancel that, this becomes 5. So this is like 5 by 13 minus, this is also 5 by 13. Wow. After doing all this calculation, your answer is nothing but 0. So 0 is your answer to this question. All right. So this is the way in which you can solve this question. Okay. So this is all that you need to know as far as trigonometry for SAT is concerned. You actually don't need to know anything, any other concept. Just like some basic questions or some basic properties, some basic values for a certain angle, that is all that you need to know, right? So if you can just remember whatever we have done on this page, this is like more than sufficient for your SAT preparation for your trigonometry, right? Nothing else is actually required. Alright guys, so that will be all as far as this video is concerned. Thank you so much for watching this video. If you like the video, please hit the subscribe button. Please do share it with your friends also. And if you're looking for any individual course, personalized classes for SAT, GMAT or GRE, you can always connect with us, right? Thank you so much guys. Keep watching and keep sharing. Thank you so much.